Next, we'll talk about effects of air pollution. Effects of air pollution on human health include direct effect and indirect effect. Direct effect include acute effect, chronic effect, and cancer. The main way air pollutants enter the body is through the respiratory tract. Large air particles are trapped in the nostrils, but the small particles can lodge deep into the lungs' air sacs and cause permanent damage to the lungs. Acute hazards of air pollution means a sharp increase in the concentration of atmospheric pollutants. In the short term, the surrounding crowd inhales large quantities of pollutants, causing acute poisoning. Some examples include smoke events such as coal burning smog or photochemical smog. And it can also be caused by accidental release of toxic gas. Coal burning smoke event is caused by a large number of soot and industrial emissions discharged into the atmosphere. The major pollutants are sulfur dioxide, soot, and sulfuric acid. This picture shows the photochemical smog in London, England. You can see that with this acute poisoning, the smoke, sulfur dioxide, and death pretty much happens at the same time. This is the isocyanate leakage in India in 1984. I think everybody in India knows about it. These are the characteristics of coal burning smoke events. First, the pollutants came from coal combustion and industrial processes. Second, the weather condition also matters. Low temperature, high pressure, low wind speed, humidity, fog, and temperature inversion can all contribute to this smoke pollution. And it occurs more during the cold season. And third, it happens more in valley and in basin. And fourth, the victims suffer primarily from respiratory tract irritation. This picture shows coal consumption by region. Basically, China consumes the most coal. Photochemical smog is basically caused from car exhaust, and nitrogen oxide, and hydrocarbons after a series of photochemical reactions under strong sunlight. Photochemical smog happens in two stages. Stage 1 is the accumulation of pollutants, and stage 2 is oxidant formation. Basically, you have an inversion here, meaning the warm air is on the top, serving as a lid, and the cold air is on the ground. So the polluted air is trapped on the ground. In this case, the car emits nitrogen oxide, carbon monoxide, and volatile organic compound. And the nitrogen oxide, as an example, can undergo chemical reactions to nitrogen dioxide with sun's radiation. And this nitrogen dioxide can further release one oxygen atom and then interact with oxygen to form the ozone. Now, ozone and the nitrogen dioxide are all components of photochemical smog. So this compound, under the sun's radiation, can form haze or photochemical smog. The characteristics of photochemical smog include the following. First, main pollutants came from vehicle exhaust, and oxidizing smoke is generated by strong solar UV photochemical reactions. Second, the weather is generally clear. It occurs mostly during the day in summer and autumn. And third, it happens in big cities where you have air pollution, right? And where you have a lot of motor vehicle congestions and poor ventilations. And fourth, the victim's symptoms generally include conjunctivitis and respiratory tract irritation. And the chronic effects of air pollution can affect the respiratory system. It can also cause conjunctivitis, pharyngitis, and bronchitis. And another one is COPD, which is chronic obstructive pulmonary disease. And it can also reduce the immunity, cause allergic reactions, and others. And in a very long term, it can develop lung cancer. Indirect hazards of air pollution include greenhouse effects, ozone depletion, and acid rain, and others. Greenhouse can increase the propagation of pathogens and the incidence of heat-related illness and mortality. It can also cause an overproduction of harmful substances such as fungi, hail, and pollen concentration. Now the ozone layer is just above the troposphere. This picture shows that there's a hole in our ozone layer, as depicted by this red circle. The hole exists both in the North Pole and the South Pole. Now the ozone protects us from excessive UV light. So why is there a hole in our ozone layer? This is because humans used this compound before, CFC. Now CFC is short for chlorofluorocarbon, or CFC. So what happens is that the UV light causes a chlorine atom to break away from the CFC molecule. Okay? Now this free chlorine can interact with ozone. And it will take one oxygen atom away from the ozone, creating a chlorine monoxide and oxygen molecule. Now, a free oxygen can hit the chlorine monoxide, and this results in a free chlorine and oxygen molecule, or O2. Now, this free chlorine can continue back here to interact with the ozone, and this will deplete the ozone in the atmosphere, in the stratosphere. So fortunately, we banned the use of CFC, and now our ozone layer is getting back to normal. Now we'll talk about acid rain. You can see the sculpture destroyed by acid rain. Acid rain is caused by air pollution. The major hazards of acid rain include it will harm the soil and plant, so the pH will decrease, and this will decrease the fruit yield, and it would also decrease the soil fertility and reduce crop yields. And of course, the rain eventually goes into the sea and the rivers, right? So this will impact the aquatic ecosystems. This would acidify the water and affect the zooplankton species and increase the death of fish and shellfish. And of course, it would also impact our health, right? And of course, it will corrode our buildings and monuments. In the last section, we'll talk about major air pollutants that affect human health. The first one is sulfur dioxide, which is a colorless gas soluble in water. It comes from sulfur fuel combustion and exhaust gas. The health effect includes allergy, asthma, and acid rain, of course. The next one is particulate matter, or PM, like PM10, PM2.5. It comes from sand dust, volcanic eruptions, forest fires and seawater splashes, combustion of various fuels, and cement plants and petroleum chemical plants, industrial processes, road dust, construction dust, and so on. The health effect of particulate matter, or PM, is that it will impact the respiratory system. It can cause COPD, or chronic obstructive pulmonary disease. It can also have carcinogenic effect. And factors affecting the properties of PM include the particulate size, or particle size. This would affect the settling velocity, deposition rate, and deposition site, and also the substance itself. Okay? The composition of the particles is also another important factor. It can be organic, inorganic, or just a simple carrier. The third one we'll talk about is nitrogen oxide. It is insoluble in water, and the toxicity, nitrogen dioxide, is higher than nitrogen monoxide. It came from thermal power, petrochemical, lightning, or higher temperature. The health effect of nitrogen oxide includes damage to respiratory system and cause hypoxia. And nitrogen dioxide also has a cancer-promoting role, mostly used in food. It can also cause photochemical smog. Other air pollution includes carbon monoxide poisoning and ozone, and lead in the gasoline. Last, we'll talk about polycyclic aromatic hydrocarbons, or PAH. PAH contains two or more benzene ring connected to a fused aromatic hydrocarbon ring. The sources of PAH generally comes from incomplete combustion. The health effect of PAH is carcinogenic effect. For example, this BAP, or benzoapirin here. Now, benzoapirin level in the atmosphere is positively correlated with lung cancer. So that's it for today. In the next lecture, we'll talk about indoor air pollution.